So this video is about explaining reverse pairs. This is a variation of count inversions, which uses merge sort, and then while doing one merge sort, we basically count the number of inversions that are there. This is of in similar lines, right? You use the similar kind of strategy to do it. So let us go to a whiteboard and okay. Before that, let me explain you what the problem is. So given an integer array nums, we need to return the number of reverse pairs in that array, and they've defined what a reverse pair is. So given a pair I and j, where obviously I less than j and both are valid indexes, we need to figure out the number of ij combinations such that nums of I is greater than twice of nums of j. I mean the value of nums of I, which is of a lesser index than j, should be twice of the value at index j. So and we need to find all these pairs. So this is the problem. Obviously there is a brute force solution which takes n square, but obviously we will not look at that. We'll look at how we can solve this problem. So what happens is merge sort. Basically what happens in merge sort is in a particular instance, we have a left array and we have a right array. So we'll try to merge these two arrays, right? And then in the process of merging, we can basically no, I mean, let me stick to merging itself now for now. So we need to merge these two arrays, right? And then both these two arrays are kind of individually sorted. So let me take one array as 1 2 5 maybe, and then one array as maybe 1 3 and 11, right? And okay, so and then this is then we merge them. Okay, the general merge sort I'll explain you in the code how that is being done. So just okay, let me explain here also a bit. So suppose we have our A index here and we'll have our B index here, right? So these are indexes that we have. Suppose we have indexes. A is pointing to the first value of the this kind of array, and the B is pointing to the first value of this kind of array on the right array, and this A is pointing to the first index on the left array. And now we compare A and B, and since now A is less than equal to B, we'll take probably A, right? And then increase the index here. So this will move forward, right? This will move forward to here, and then again now B is smaller, so B will move forward, right? B is gonna move forward because B is smaller, and then we populate one here, and in this way we just keep on moving. Let me finish this. We'll take suppose now A is smaller again, so we'll take 2 and move the A index 2, right? And then B, and between B and A, B is now smaller, so B will be moved forward, and then 3 will be placed here. And between A and B, now A will be moved, so now A will move and move beyond valid bounds, right? And then 5 will be put here, and then B is still remaining, but A has moved beyond valid bounds, and as soon as one of the indexes move outside the valid bounds, we'll be exiting this loop which does this merging, right? And then we'll look at if any of the indexes have not reached their are still in the valid range. So B is still in valid range, so we'll just, since this is sorted, right, then we just pop these elements out from B till B reaches an invalid state. So now we'll just pop the current index at B and try to move B forward and move it to a value index which is out of range. So we'll do that. Let's move B forward, and then obviously then 11 has to be put here, and then B is out of range, and that means we're done. So as you can see that from these two sorted arrays, we have derived another array which is sorted, right? This is also sorted. Now having the now okay, now so that, and our for our solution we also need this, we need two sorted arrays, and then we'll able to figure out our answer. How will we able to figure out our answer? Okay, so let me focus on that now. Let me take this array again here. I will try to populate this our requirement using the same array. Again we'll be moving, we'll take ix here. let me delete this and also this. Since I have used ix and jx in our I mean delete ix and jx in our code, I'll be using that here. So this is ix, right, and this is jx. And now we will try to figure out pairs in which nums of ix should be greater than 2 into nums of jx. Okay. Okay, so first is a simple comparison. We'll basically take two for loops, right? One for loop would be basically of ix within the valid ranges, and then the other for loop will be, and within this for loop there is a for loop of jx. That's how it is, right? And then and then obviously we'll start uh, comparing, right? And then another thing is ix will always be smaller than jx. Okay, here and jx was here, and now let us see whether this comparison works. We'll use this comparison and keep moving ix and jx forward accordingly, right? So let us see. Now for the first case, obviously ix is not greater than 2 times of jx. Nums or nums ix here is not greater than 2 times of jx. So we'll move this ix forward. Let us move this ix forward. We'll move it to here, right? Now and now it's still not true, so we'll keep moving this forward. And now it's true, right? And now it's true, so we'll move jx forward and get okay till the point. We'll keep moving jx forward till the point it is not true anymore. So I think if we move here, then only it is not true, because 2 times of 3 is 6 and this is 5, so 5 is not greater than 6. So here it fails. So this generally these two arrays, okay, one more thing I want to tell you, that generally these two arrays are given in such a way that this is just a mid. So basically these two arrays are part of the same array, and they are divided. I mean, they're the starting index of the right array just one more the starting index of the left array. So this is mid plus one. So how many pairs did we get for this particular ix? Right. So this was, sorry, for this particular ix, when it was at 5, how many pairs did we get? Which was only one pair, right? So this is this. So this is the length that we got, right? And so what would be the length? It will be jx. Let me use another ink. It would be jx minus 1 minus mid, right? Jx minus 1, and it started from mid plus 1, so minus mid plus 1 plus 1, right? Because basically the equation is, if there is an index a, there is an index b, then the number of values in this range is b minus a plus 1. So that is what I'm trying to do here. Okay, and this one would cancel out from this one, so this will become jx minus mid, and then this should be minus 1, right? Jx minus mid minus 1. So this is the number of elements. This is the number of elements for this instance. So what we'll do is that we'll keep moving ix forward, or for a particular ix, we'll look at the jx and then we'll calculate this. This will give us what is the count, what is the reverse pairs count when the first index of the reverse pair is ix, is ix. Okay. Hopefully you will able to understand what is happening here. Things will be even more clear when I look at the code. Now actually let us look at the code, right? So this is basic merge sort code. So we have this reverse pair function which is taking nums as input. We'll do a merge sort, and then this will take care of everything. And this is just a print statement which is not required, right? We just do a merge sort and which will take care of everything. And now let's see what's happening in merge sort. we I have not prepared, I have not made any a different the way I'm doing this is I'm passing the array, and to represent an sub array I would be passing the main array and the ending and starting and ending indexes of the main array, which can represent the sub array, right? So that is what I'm doing here. Okay, so now we go to the merge sort. If I equal to 0, there is nothing to sort, so we return. And basically here there is only one single index, so there is nothing to be done. And then we take the mid, right? I plus j by 2. And then we do a merge sort on the left array, merge sort on the right array. As I told that the ending of the left array is one less than ending of the right array, right? I have less charge. Let me connect my charger. Okay. And then we merge. So we sort left part, sort right part, and then we merge, right? Let us look at what happens in the merge function. So what happens in the merge function is we know that before the call of the merge function, the left part is all and right part is already sorted. So we don't need to worry about that. So we'll have I mean the range between ix I to j mid is sorted, and the range between j and this is j equal to mid plus 1. So mid plus 1 to j is sorted, right? And what is, let me explain what is happening here. So j is jx is we take the start of the right array, which I had explained here in the whiteboard. The j starts from here, which is the right of the right of the start of the right array, right? And then obviously j will go till we have till it is in the it is the it is in into the what is this called valid bounds, right? Because j is the bound of the right bound of the right array. And then we'll for a particular I will continue till we will get to a place where the condition fails, right? So okay, as long as the condition is true, and this is as long as jx is in the valid bounds and the condition is true, which basically checks that whether I is greater than 2 times of j, or value of I is greater than 2 times of that. So this is a basic function which checks this and nothing else. Then we'll increment j, and then finally j will come to a place, and then I've showed you how this function works. So this is jx minus mid minus 1, or this can be represented in this way: jx minus mid plus 1 whole bracket minus, right? So this is the same thing that I mentioned there here, this formula. This can also be written as jx minus mid plus 1, right? It's the same thing. Okay, so now here we already counted the count, and the rest is basically simple merge sort, in which we take the initial left bound of the left array, left bound of the right array. We initialize a result matrix to store the result, and then we'll populate, we'll fill nums with it. For temporarily store the result, this result this is the reason behind initializing this result array and the purpose of this result array. So how many elements are in this array? It should be j minus 1, j minus I plus 1, because the left bound is I and the right bound is j, right? And then obviously we'll basically iterate, as I mentioned, till any of in both of this A and C. So this whatever I showed you here in the whiteboard as B here initially. So initially I mentioned this, right? B here. So that was actually C. So C means C is helps to track the right array from beginning to end. While explaining in the whiteboard, I took that same element as B. Obviously, if num say less than C, we'll move A forward and put A into the result list. And if it is not so, then put C into the result list and put C forward. And what if A is remaining? A is not yet at the end, then we'll pop all the elements in the left array and put it into the result, and same will do for the right array. If something is left, then we just pop everything, all of them sequentially, and put it into the result, right? And then we'll fill nums with the result. This is straightforward code. So yeah, I think this is it, right? This explains everything. I probably need to explain something else. Let me think about it. Mm, yeah, there is a. I want to explain one very important optimization here, which I think you would have overlooked. For example, you can see that JX is never getting reset here because uh, if for a lesser I, all right. For example, let me go to the whiteboard and check. So for example, how do I do it? I 2 3. I need to take i's very high, so 5, maybe 6 and 7, right? And then 1, maybe 2 and 3. So when ix will be here, jx will go till here, because for this these pairs are basically satisfying the equation. And then jx is still kept here when 6 comes in, because I was smaller than 6. I satisfies the condition that num size is greater than 2 into nums j. Then since 6 is greater than I, then 6 will also be satisfy the condition of these cases, right? So these don't need to be rechecked here. This is the optimization. You can directly start with here. Okay. So that's why you can see in the code jx is never getting reset, and that gives a lot of speed up. Okay, I think you understood the problem. I'll see you in the next video. Thank you.